Black holes are among the most awe-inspiring and enigmatic phenomena in the cosmos. These invisible giants exert a gravitational force so intense that not even light can escape. With masses ranging from a few solar masses to billions of times that of our Sun, black holes remain some of the most fascinating puzzles in modern astrophysics. Until recently, much of what we knew about black holes was based on theoretical models and indirect evidence. But now, thanks to decades of research and advanced observational technology, scientists have begun to uncover what truly lies inside these mysterious voids. A groundbreaking announcement was recently made by Dr. Michio Kaku, a well-known theoretical physicist. He revealed that researchers have taken a significant step forward in unraveling the secrets hidden within black holes. This discovery sheds light on previously unobservable aspects of black holes and may fundamentally change our understanding of these cosmic entities. So, if you're passionate about space and curious about the unknown, you're in the right place. Subscribe to Waves Discovery, like this video, and turn on the notification bell so you never miss a journey into the universe's most mysterious corners. Although many of us have a general idea of what black holes are, the actual mechanics and their implications are far more complex. The idea of a black hole wasn't even accepted when it was first proposed. In 1916, Albert Einstein published his general theory of relativity, which provided a revolutionary new framework for understanding gravity. His equations predicted the existence of regions in space where gravity could become infinitely strong, what we now call black holes. But at the time, this idea was considered more of a mathematical curiosity than a physical reality. It wasn't until the 1960s that real observational evidence began to emerge. During the study of the Cygnus constellation, astronomers discovered an unusually bright blue star emitting powerful X-rays. These X-rays didn't behave as expected. Instead, they appeared to be pulled toward an unseen but incredibly massive object. Upon further investigation, scientists determined that the star was orbiting something invisible, something with an immense gravitational pull. This invisible force was none other than a black hole. The object was named Cygnus X1, and it became the first widely accepted black hole candidate. It lies about 6,000 light-years away from Earth. This discovery was not just important, it was revolutionary. It confirmed that black holes were not theoretical abstractions but real, tangible objects in our universe. Scientists soon realized that black holes might not be rare at all. In fact, it's now estimated that there could be as many as 100 million black holes in the Milky Way galaxy alone. However, due to their nature, being invisible against the backdrop of space, they're notoriously difficult to detect directly. One of the most terrifying aspects of black holes is their gravitational pull. The force is so strong that once an object crosses a certain boundary, known as the event horizon, escape becomes impossible. Not even light can flee this gravitational prison. Matter, energy, and even information that fall beyond this boundary are effectively erased from the observable universe. Theoretically, if a person were to fall into a black hole, they would be stretched into a thin line, a process called spaghettification. This grim fate would occur slowly from the falling person's perspective, though from an outside observer's point of view, they would appear to freeze at the event horizon. Understandably, this raises questions. If black holes are so powerful and so dangerous, are we at risk here on Earth? Thankfully, the nearest known black hole is approximately 1,500 light-years away, which is still quite distant in cosmic terms. For now, Earth is safe. But their presence does provoke a deeper scientific and philosophical inquiry into the structure of the universe itself. A major breakthrough occurred in 2019 when scientists released the first ever image of a black hole. This historic image was of the supermassive black hole at the center of the galaxy M87, located about 55 million light-years away. The Event Horizon Telescope, a network of radio telescopes around the globe, worked in synchrony to capture this image. Over multiple nights, vast amounts of data were gathered and meticulously pieced together to create the final picture. What they found was astonishing: a glowing ring of gas and light surrounding a dark central region, the black hole's shadow. This image was far more than a visual milestone. It provided crucial insights into the nature of black holes. We now know that black holes are not simply voids but are composed of multiple complex layers. To reach the center, one would pass through three distinct zones. The event horizon. This is the boundary where escape becomes impossible. It marks the point of no return. Once an object crosses it, it is irrevocably pulled toward the center. The photon sphere. Just beyond the event horizon lies a region where light orbits the black hole. In this region, the gravitational pull is strong enough to trap photons in a circular path. It's a dynamic, swirling boundary where light dances around darkness. The singularity. This is the heart of the black hole, a single point of infinite density where the known laws of physics break down. It's here that all the matter and energy consumed by the black hole are compressed into an unimaginably small space. But what happens inside the singularity? Could there be something beyond? This question has led physicists to explore the possibility that black holes might not be the end, but instead, a doorway. One of the most exciting theoretical ideas is that of the Einstein-Rosen bridge, more commonly known as a wormhole. This is a hypothetical tunnel through space-time that could connect two different points in the universe. Or perhaps even two entirely different universes. Imagine folding a sheet of paper and poking a hole through both layers. That hole, or shortcut, is essentially how a wormhole would work. If such structures exist, black holes might be the entrances, with white holes, theoretical opposites of black holes, serving as the exits. White holes, unlike their counterparts, would expel matter and energy, never allowing anything to enter. If a wormhole connects a black hole to a white hole, it could potentially serve as a cosmic portal. The implications are staggering. It means that a person, or even a spacecraft, could theoretically travel across vast distances or even into another universe in moments. However, before we pack our bags for interdimensional travel, it's important to recognize the challenges. Wormholes, according to current models, would be highly unstable. They might collapse instantly unless stabilized by exotic matter, something that remains entirely theoretical for now. No wormhole has ever been observed, and even if one were found, using it would involve navigating enormous gravitational forces and extreme radiation levels. Still, the idea that black holes could serve as bridges rather than dead ends has reinvigorated discussions around time travel, faster-than-light journeys, and the true nature of space and time. These concepts blur the boundaries between science and science fiction, and yet they remain grounded in real equations and mathematical models from general relativity. So, what do black holes really represent? Are they cosmic vacuum cleaners, endlessly devouring matter and light? Or are they the universe's ultimate gatekeepers, guardians of deeper truths and gateways to other realities? As our tools and understanding continue to evolve, we edge closer to unlocking the true nature of black holes. With telescopes like the James Webb Space Telescope and upcoming missions that may one day send probes into the very edges of these cosmic giants, the future of black hole research looks promising and thrilling. What do you think? Are black holes the end of everything, or the beginning of something even greater? Could wormholes exist, and if so, might they connect us to realms beyond imagination? Let us know your thoughts in the comments. And if you enjoyed this deep dive into the dark heart of the universe, don't forget to like this video, subscribe to Discovery at 2.0, and hit the notification bell so you won't miss what's next. Until then, keep looking up, and keep wondering.